started at Yahoo as an attempt to actually reduce the efforts on, even because people realize that even you are a core Java programmer, they essentially had a lot of overhead in thinking or understanding the whole process of mapping and reducing, and then optimizing it is another level of complexity that they used to face. So in that sense, like people wanted to actually try out something that is all more abstracted, that involves a lot of specific data processing rather than more of a general level of so that is what you call it as your Apache Pig. So Apache Pig provides a level of abstraction on top of the data that we have. So this is something that we'll have to understand, and then moving forward, will understand why not MapReduce. So when you say why not MapReduce, what are the primary reasons for not opting for MapReduce? Because MapReduce is the default option that you have, and still it is a better option because in terms of performance benefits. So let's understand why we are not going for MapReduce when you actually have something towards pick. It essentially has something, it is more of a programmatic model, which essentially has something called a map function and then a reduce function. So, which essentially requires n number of stages in terms of map reduce, and it involves a little more challenge in terms of getting that executed. So, the ideology, understanding it as a concept is all fine, executing it or writing or converting your logic inside into a map reduce paradigm is what the whole complexity is. So when you say Pig is a scripting language, it is essentially a scripting language primarily focused for data processing. Something that is more optimized or which is more generic. Something that is more focused is more optimized, because when you say optimized, or like it actually facilitates the programmers to have some kind of ready to use functions. When you say Java is not primarily meant for data processing. Java can power your mobile phone, can power your set-top box, can power anything that runs anywhere. So in that sense, okay, Java is more of a generic programming model. So in that way, okay, Hadoop is something that was written on top of Java. So your native API supports your Java level of MapReduce programming. So that is one thing. So it is not always required. So when you say Java is not the only thing, you always have something called Pig as a scripting language. This Pig is a scripting language where you have specific data structures that is all more focused on data processing alone. So which means like you have a number of multi-valued functionality, you have something called nesting, you have something called bags, you have something called maps. Those are all different high-level data structures that you might actually want to deal with in terms of your data processing. The same thing if you want to do that in Java, like you will have to write your own data structure. So that is all unwanted complexity that you wanted to take up. It also has some kind of ready-to-use functions similar to joins, distinct, your n-gram calculation, or your actually merging all your data, your grouping. So you have a number of options to actually proceed with that. So that is what your pig has advantage over your usual produce programming. Your pig has something called Pig Latin. Pig Latin is a primary place. It's a scripting language. It is essentially you call the language the script as a Pig Latin, so that Pig script you write it as a Latin, and then you actually execute that on the environment that we have. So which means like the execution environment itself is something that you can use it on top of Hadoop. So that is what the funda we need to understand here. Here Pig is more focused on getting the data processed. So that is what the primary focus is, nothing else. So that is what the whole funda here is. And there are two execution environments available for Pig. Pig can actually execute on a one single JVM. So there are few people who wanted to actually try out Pig or want to actually practice Pig rather than on a Hadoop cluster. So they want to get checking whether their logic is working or not based on a simple data set that they actually use. So that way, like there is some option called local mode Pig installation, but I don't really recommend that at any point. Always stick with the Hadoop based, that is a production level Hadoop based execution. So this is the actual place where the actual queries, actual Pig scripts will be executed as a MapReduce program inside your Hadoop cluster. So a Pig Latin program is primarily, it involves a series of steps. So when you say a series of steps and operations, that is all transformations that they call it as. Okay, the data, the once you load it, So once you actually import the data, you need to actually every step will transform the data itself in the way that you wanted to actually process. So that is what the whole funda here is. So the operations described are all like similar to this. When you say the transformations are all going to process, once you load the data, then you process your data. Then you have something called relation names. Relation names are the actual value or the variable names are similar that you actually call it as, which will actually contain the what state your data is all available at that point. So that is what you call it as relation name. So the whole focus is primarily on the data rather than on the nature of execution. So again we are focusing on here. So why we are going for pig? So this is one common question we have, like, okay, why not MapReduce? We have seen why we are going for pig. So essentially in terms of MapReduce the life cycle, the development life cycle for MapReduce is quite high because of the fact that your MapReduce programming, it takes its own time in terms of actually getting any developer up to speed to understand things in terms of mappers and reducer, and then execute that, and then push that into a cluster and get that whole process running. So that is one thing, and basic thing that actually delays the whole process is like you'll have to compile, you'll have to package it up, you'll have to get the jar file. Yes, Edward, you're right. Essentially, it can also be used as a ETL. Yeah. Fine. So coming back, so you essentially have a number of applications. So you essentially have a number of processes that is all required for you to get completed to submit your MapReduce or your Hadoop job inside any Hadoop cluster. So if that is the case, like you'll have to write a mapper reducer, compile it, package it, and then submit it to your whole Hadoop cluster. So in that way, like the actual the time required to actually even execute or try out few things itself is all taking a lot of process in this kind of development cycle. So because the structure itself, the actual standard itself is this, so we can't really complain what MapReduce. Rather than that, Pig provides you an even easier interface. You also have something called Streaming API. Streaming API is a API through which you can still you can still run your MapReduce programs from non-Java programming languages like Python, Apple, or Ruby, or any other thing, using something called Streaming API. Even if you do that, the final process is involved is again the same. So those are all something that we can actually avoid when we go for. So the primary advantage of Pig is like it can scale up to several terabytes of data. So when you say scale up to several terabytes, it is quite relevant for anyone to actually get that ready and process that, because when you say big data set, there is nothing called a restriction in terms of data, in terms of you process with Pig. So in that way, like we have a lot of advantage because learning a little scripting language and learning that very good. So that is going to actually help you a lot rather than learning something Java right from the basics and then making your skill set ready for your Java mappers and reducer. So there is a comparative study between actually your MapReduce programming in Java and your Pig scripting. So Pig actually has its own advantages. MapReduce still has its own advantages. Let's see what all there. So to make it easier for researchers, you can still use this Pig for actually any kind of data set that you pick up, because Pig is primarily focused for unstructured data. So which means unstructured data is something that is what the usual data that we get. So not every data that we call will be a structured data. So in that way, like Pig is primarily focused also to deal with unstructured data. If you have structured data, it is even well and good, but unstructured data is something your Pig actually focuses. Very supportive even for programmers, because you already have set of functionalities that is all already implemented, rather than asking your actual the programmer to write the logic even for sorting or finding the distinct values in terms of Java or any other place. Like you with Pig, you essentially have the operators or your transformation operations. That is all more of a functions that is all available for you to execute and get the whole process completed. So that is what you call it as we mean by several commands. It is all predefined commands that will be more frequently used in terms of data. So when we deal with data, you will have to join data, you'll have to find the distinct values, you'll have to actually group the data. So these are all some common operations that you can actually get things done with your Pig itself. And you also have something called the whole data itself is all processed data can be processed in PIC. So, but even before that, PIC can be used as a POC or some kind of level where you want to get some task completed or you want to try out few things whether it is possible or not. So that is what you call it as sample run. So the sample run, which will give you a clear picture on okay, what are all the different input data sets that you have, how you are going to process that, and when you actually say 1 terabyte of data, that 1 terabyte of data will not really be the whole 1 terabyte of data that you want to process. So to actually get started with that, so you might actually want to pick up some 100 MB of data. So using that, you want to actually do some kind of querying. That is all easily possible with your PIC. So rather than again writing a MR program and compiling it and then executing it and seeing that okay, it is not the right place. So here PIC is more of a scripting language where you can just edit the file and then execute it in some another 2 seconds. So rather than your usual process of compiling and getting the whole thing ready. So PIC also has something called okay, Edward's question. Oh, sorry, Harish question is also there. Can I use both MR and PIC to handle data coming from various source, structured and unstructured? Essentially, yes, but when you say so, when you say like okay, essentially it is possible, but the purpose behind we going for PIC itself is not to go for MapReduce. Again, when you say okay, MR and PIC, so MR or PIC to handle the data coming from various source, structured and unstructured. Yes, in fact, yes, that is what the whole process is, right? So from various sources means you need to collect it and push it somewhere else. There are also a few connectors available that can pull the data from a different source also. Everything is yes, it's possible, Edward. Harish, you can go with your question.
Yeah, the question, can you actually go to 3 slides back where you had the streaming one?
Yeah.
Yeah, so here it says like even with streaming, which removes the compile and package setup step, right? So in MapReduce,
Okay.
I think we write a Java program, we compile the Java pointing to the JDK and then execute it, right?
Yeah.
So what does this mean? Like in how will streaming designate the compile and package step?
Okay. Okay. So when you say if you don't get
Like
confused too
say
much or don't get too far, but this should not really confuse you too much. You have two options. Like primarily, Java is not the only way to write your MapReduce program. So agree with that. So you
right,
also have something else called
yes,
streaming API. When you say streaming API,
right,
streaming API is going to provide you something called an option even for non-Java programs to be executed as mappers and reducers. So in that sense, like
yes,
you don't really need to actually compile the whole stuff. Rather, you can actually give it as a script itself. So that will be executed inside your, like it is not a script, it is one line program where you actually give it to your Hadoop jar. You specify, okay, this is what the functionality. This is another, you have a program for mapper, you have another program for reducer. Using this, okay, this mapper's output should go through std out to the next reducer. So that is how the whole process would be. Even though that is the case, you still can avoid just compilation and package step, but essentially the whole process of submitting into your cluster, it's all manual. You will have to type the whole stuff manually. So you need to specify what is a mapper, you need to specify what is a reducer. So those are all still required. So that is what the whole complexity here is. Okay.
so even with streaming behind the scene, it invokes a MapReduce process.
Yes, in fact, yes.
Okay,
When you say
okay.
you are writing a PIC script, behind the screen it is a MapReduce program.
Right. It's only that the mode is something different. We are doing it either
It's
by Perl,
abstracted interface
Python, or
that we write in script.
okay. But behind the
Yes,
scene,
yes, yes. You are right.
it's still a process on the it's a process on the
MapReduce.
main node and MapReduce. Right.
Yes, you're right.
Okay.
Yeah, fine. So getting back to the slides. So we have something called pig UDFs. UDFs are all user-defined functions that is all available for us to actually call some already predefined functionality. Like okay, you are frequently using on you are working on some e-commerce site and you want to find the top trending or the top 5 users whose pricing or the purchase history is very good. So you would have already written a function of that. So rather than writing it often, so you can actually register that as a UDF and then load it when and where you want it. So those are all what you call it as pick. So this also adds to more of a extendability. So in terms of your Java, you can't really do it literally because in terms of Java, everything is all tightly coupled within a program. You can't really have more modularized unless you get into the program and copy the script and write another function and then copy it inside your program. So in that way, picks UDFs are all quite extendable. So you can actually literally say, okay, load this and it will be actually available for you, provided if you are already having that UDF defined. So it is yeah, these UDFs are quite more reusable because this is all already available and you can register that jar files also. You have something over here. So that is what we call it as some few key concepts, key things, key important factors that we need to understand. Pig is not suitable for all processing tasks. When you say all data processing tasks, you can actually recoin that in a different way. Pig is not suitable for all tasks that can be done on a Hadoop cluster because Pig is primarily focused primarily on the data. So there are few scenarios Hadoop can also be used for computation, not just for data processing. So one good example is finding the pi value, estimated pi value. So you say okay 3.147. So that is what the pi value is, but rather you wanted to find the 10 more decimal values of your 3 pi value. So how do you do that? It involves a lot of mathematical computation. Or you are going to use your data node for you are going to use your task tracker or you are going to use your whole Hadoop cluster for computation rather than more of a data processing. In that sense, Pig is not the right fit. Pig is primarily focused only on data processing. So even though it is a pi value estimation, end of the day it is also a data, so which means it is a one single line of data. So that we need to actually understand. That is what Pig is not always meant for every data processing task that can be done. So like, but 95% of all your MapReduce tasks can be pushed into Pig because 95% of your MapReduce tasks are all primarily focused on data centric operations that your Pig can handle. Right. So and moving forward, your MapReduce is again similar to your MapReduce, your Pig is again a batch processing tool. So when you say batch processing, it again requires some more time to actually process and retrieve the results and say get you back to get back the results what you would have expected. So because end of the day, Pig also internally runs something called MapReduce. It is again a batch processing. So if you want to actually perform the query, so which might actually reduce your development cycle and which might actually increase a little more processing time on your cluster. So then Pig is the best fit for you because Pig is primarily now encouraged by several enterprises for kind of resources because we ourselves in India we have our clients itself have 70 plus openings for Pig alone. So basically the reason behind that is Pig projects, the people, the clients itself recommend Pig because of the reason that the development cycle is very less because you at least know okay yes or no literally in some another few days rather than taking some few times or POCs or all like something that is going to take a lot of time or even in case of your MapReduce. So you don't really need to break your head thinking in terms of MapReduce at least for the initial POC or getting some basic clear data set. When you say your client says okay his query is quite simple, I just want to understand the pricing trend of the user that is all during the month of January to February. So his question is quite simple. Rather than for to process that, you should not really spend some 1 week time with your team and get your MapReduce program running. Rather, you have the data set, you can actually still get some kind of analytics in some one day with processing or analyzing your whole big scripts. So that is what the difference is. So in that way, so the whole thing is all quite possible because anyway, like Hadoop or MapReduce program is going to be an offline processing, which might take some 3 hours. So rather than taking 3 hours, okay, when you're going for MapReduce, it might take 3 hours. Okay, when you're going for Pig, it might take some 3 hours and 20 minutes. You can still spend some extra 20 minutes on that because anyhow, it is all a data offline processing. Okay, offline processing, some little more 15 minutes is all fine that you can because the advantage that you utilized was on lesser development cycle. You did not spend so much time on getting the whole MapReduce job running successfully. Rather, you would have got that easily with your Pig. Got it? Something we need to understand finally. Pig is not something that you can directly compare in terms of performance with your MapReduce. Always MapReduce programs are performance oriented, are performing better than your Pig, because there's something, it is more generic, it is not so much optimized. Because in terms of MapReduce, if you write a MapReduce program, it would be more optimized, because you clearly know this is what the function, that is what the function. Here you don't really write any MapReduce, but essentially you process the data and that is all converted as map. So the framework itself tries to make sure that it is all quite optimized, but the version that is all coming in the upcoming version, the of Pig, which actually narrows down the whole process of the latency between your MapReduce and your Pig. So that is what the funda here is. So this is what the final conclusion is. If you say, okay, you want to get some task done, so you're not so much specific about the performance delay that might actually happen. That might be in terms of few minutes, but essentially you wanted to get the whole task running faster. So you want a lesser development time. Pick this answer for you. Got it? Any other question?
Sarna, this is Harish.
Yeah.
Yeah. So
Yes, Harish.
are you continuing
Yes,
with
go
the
ahead,
class,
please.
or is the class completed for today?
No, essentially I want to get some input so we can actually continue on the next class also. Throw your
Okay.
questions. Yeah.
Okay. So the thing is, like, for Pig, right? Do we need to install Pig again on Hadoop, or
Yeah.
how it works?
Yes, yes, yes. You are right. You need to install Pig. Pig is not a component of your Hadoop.
Okay. So, but
Pig is
so
another.
it also.
Pig is a different component that depends on Hadoop. Pig is not the core
Okay.
component of your Hadoop, so we need to install Pig manually. Yeah.
Okay. Okay. So when you say manually, like in terms of the Hadoop release, we'll probably have something like a compatibility version of Pig which goes with this Hadoop 1.01.
Absolutely. You're right. You're right. You're right.
That what it is?
Basically, not every Hadoop
Then
version would be supported by every version of Pig. There is some compatibility check. But for the version that we are using, you can recollect what is Hadoop version we are using here. Any
probably
idea others? What was the version that we
1.01.
used? 1.0.1, right? Yes, perfect.
So given
Yeah,
that,
we'll be
right,
showing
like
that
okay,
the next session. 1.0.1 is what we recommended. Okay, fine. So the latest version
okay,
of
then
Pig
I'll
is 0.10. 0.10
okay,
works out with
okay,
your 1.0.1.
okay. Okay, I'll let you continue with the class, and then if there are questions, then I'll.
Yes. In fact, yes. In fact, yes. Because Pig is more focused on unstructured data. When you say something is more focused on unstructured data, structured data is in fact easy for it to process. Straightforward question. Yes. Uh, that is one primary thing. That is one primary thing. The primary thing is not always about reducing the task of the things. So there are few scenarios, or there are few companies where like daily they'll have to write 10 number of MapReduce tasks. So or 10 number of data processing tasks. In that case, like you can't really afford to spend a lot of development cycle. So that is one thing. So end of the day, it always boils down to that level only. But your more focused on keeping your data flow more clean. So that is one focus. And the next focus is whatever, like, in any idea why the name pig? To answer your same question, you say, okay, pig can pig answer handle both structured and unstructured. Yes, the answer is yes. The reason behind the name pig itself means the same, because pig can eat anything. That is what the reason behind it. No, that is what the actual reason behind the name pig is, like, pig can eat anything. So which means if data that is dirty or the data that is structured or data that is semi-structured, it can still process it. There is a meaning behind that. Yes. Yeah, that is a primary way. That is your primary way of running map. What is it? Okay. So essentially, when you say a data flow, I just want to mention something called, when you deal with the data in terms of pig, you will not really be dealing with any of your MapReduce program, but there will be a step-by-step approach on what you are going to do with the data. First step, you will be loading the data. The second step, you will be specifying the relations. The relations will be specifying, okay, how you are going to define the schema. Then the next step, you will be filtering the unwanted data. The next step, you will be actually working on your logic. So which means it is more of a clear picture on how the data is all transforming from one step to another. The same thing you can't really see in terms of MapReduce programming. That is what I meant by. Okay. No, only on one machine should be fine, because similar to any other stuff, you can understand something called, when you say, even though we say pig will be converting things, the whole pig script itself will be converted as a jar file. So the jar file is something that can be acceptable by your name node or your master node to actually execute the whole setup. So that is what pig will do. Because for pig, you will just need to specify what is a cluster, where it runs. Once you specify that, your pig will actually, the script that you actually give, right? Once you execute that script, pig itself will compile a jar file or get a jar file running, and that jar file would be pushed into your Hadoop cluster to process that. You don't really need to have pig install on each and every machine. So it is all internally. That is what the whole project of pig itself is. So when you say a jar file, that will be an internal process. We don't know it is all happening, because the whole project itself is about getting a more abstracted interface for you and running it in the background as a MapReduce program. You got it? It's pretty. Yeah, go ahead, Rakesh. Sorry, your voice breaks. Can you come again? Can you type in your question? I can't really get the whole picture of it.
Sarna, are you able to
No,
hear
no, no.
me? This is
Just type
Harish.
in. Yeah, please go ahead.
Uh,
Yeah.
are you able to hear me?
Yeah, yeah, yeah.
Yeah. So
Very well.
let me repeat the question what Rakesh is saying. So
Okay.
Rakesh, what he's asking is, okay, imagine there is a big Latin script which we wrote, okay,
Okay.
and as you said, this is a data flow control, right? Like say,
Okay.
previously there was somebody has to write a mapper, write two mappers, and then write a reducer, and then probably write a combiner and go. let us say if Pig Latin provides us the structured or unstructured data dealing, and we have data structures defined there, and there's a logic which says, okay, select everything, then I need to join with this, and then further process. His question was, at each step, does it automatically fire a MapReduce job behind the scene to do that particular function, like let's say join, or
Okay.
it takes the complete script and converts
Okay.
the whole thing into one single jar file, and that goes as a single MapReduce job. That I
Okay.
believe that was his question.
Perfect. Perfect. So is it the same, Rakesh? Yeah, perfect. Yes, your answer is primarily it is more of something we need to understand here. So it's again more of a question that I can give you back. So what essentially does that mean is there are few scenarios that will involve a complex scenario. Okay, which means like okay, loading a data is not a MapReduce task. Loading the data in terms of Pig, you just specify okay, this is what the operation is. Let me actually take you through that. That is going to be covered up on the next session, but anyhow, I'll just take you through some scripts. See here, so this is something a pig operation that you can actually see. So just a minute. So this is nothing but you are actually loading here. So when you say you are going to load a data here, Pig will actually not do fire a MapReduce program here. Essentially, there are few scenarios how to process things up. Even here, Pig will not necessarily be actually like here you are going to load a data, but this is the next step. This might involve a lot of computation. Here your MapReduce program will be triggered. Got it. Similarly, on the next step, there might be something called actually filtering. Filtering process will not just always require a MapReduce programming. Once you get the whole thing, you have two options. So one is your whole Pig script. You can execute Pig as a whole script, or you can execute Pig using something called grunt. There is a command line, there is a shell for Pig called grunt, where you can actually execute your commands to actually try things out, similar to your Java interpreter, or sorry, similar to your Python interpreter or your IRB. So where you can actually execute some commands or some functions literally to test things out and then compile it as a whole program and run it. So similarly, Pig also supports that. You can still run some few commands one by one over your Pig grunt. Otherwise, you can actually write the whole script and it will be actually given to your Pig program. Pig space at Pig script. Once you execute that, it will itself create a jar file whenever there is a requirement, and then it will process it. End of the day, we will be actually specifying something called similar to this load. Load function is what you will be used to actually import the data. Similarly, you have something called store function. Store function is used to write the data back to your file system, your HDFS file system. So until that process, there are few complex scenarios. Whenever there is a complex scenario that is not straightforward, that will involve a MapReduce program. Got it? Okay. Any other questions? No, this is I am going to cover. This is a even bigger topic. I am going to cover this only on the next. Involves a lot of inputs, understanding of Pig. So we will be getting into the hands-on sessions on Pig on the next class. Any other questions we have? Yes, Rakesh. Yes, Edward, like you would have missed what? Sorry, Rakesh. Edward, we can have this discussion offline. You can just ping me over Skype. We'll discuss what you missed last class. Right. Yeah, yeah, Rakesh. Sorry. Sorry. Okay. 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 In fact, yes, if you don't know anything about configuration management system, so if we are not using any other configuration management system, so our manual process would be helpful, but this is absolutely not at all a production level scenario. So for two nodes, this is what the purpose is. You would have heard about something called configuration management system. So configuration management systems are all something that is all extensively used in every company, where essentially to actually do some scripting changes or any other changes over a network, or when people manage 1,000 node cluster but still they want to change some kind of a host name changes or some kind of configuration change where the web server should not run on the default 80 port but it should run on 81 port, you can still do it from one single place. That is what you call it as configuration management system. Your question seems to be right, but essentially you also need to understand that in production level scenarios it is already there. You don't really edit or you don't really need to copy everything manually. The purpose is, the whole funda behind this is you are going to place the same set of configuration over there. So how you are going to do it is, one is manually doing an SCP, the other one is using some configuration management tools. One among them is your Puppet, few among them is your CF engine. You have something called Chef. You have a number of options to do that, but that will be taken care by your admin. No, configuration management itself is a different topic. I can still take 100 hours on that, but that is not the whole purpose here. Configuration management is something more of like when you say you are running 100 node cluster, so you still want to actually move, like change one single file or update every file. You need to create a directory called abcd under slash data. You can still use configuration management to automate your whole Hadoop installation itself. That is also still possible. So just if you find time, you can just look at what Puppet is, what CF engine is. Look at that. That should give you a clear picture on what we'll be doing. You are right. No one is going to do that manually for a 200 node cluster. So that is where this kind of configuration tools comes into picture. I believe many of you would have already heard about that. No. Others, like, because we have people from administrative background also here. I'm just asking them. So because they clearly know what that means. Conero, you would have heard about that. Yeah. Sorry. I can still tell, but I don't want to dilute the whole thing because I can still, I'll take my own time on explaining that, but let me be more brief. So when you say Puppet is a project that was actually started primarily very not so old, but CF engine was quite old. The Puppet project is actually penetrated into almost every company in terms of configuration management. So what do you mean by configuration management is automating your whole infrastructure. That is what the whole purpose of configuration management, or maintaining your whole servers, maintaining, or without even any manual intervention. So everything else should actually happen very smooth. So that is what the whole purpose of it. So what might be the day-to-day task that any administrator or any infrastructure specialist would be doing is like, okay, managing your servers, making sure that everything else is working, okay, moving your data, taking a backup, or a number of purposes, the number of tasks you have. But essentially everything can be confined within some kind of specified task, okay, in that sense. So these kind of tasks becomes very tedious in terms of actually distribute managing it over a network. So that too, having data centers across the globe and still managing it sitting from one single place is absolutely not an easy job. So you have something called Puppet to take care of it. So Puppet has something called nodes. You also have something called a Puppet server, and you also have something called Puppet agents. You'll have to install a small agents inside every machine that you want to actually manage. Once you have that agents installed, later on you don't really need to SSH into that machine and do everything manually. Rather, from one single place, define a class. Okay, this is what I need to execute. You can just specify, okay, install Apache 2, which means it will install your HTTPD, that is your web server, on all those machines even without your intervention. So once you execute that, everything else will be actually picking things up. So that is what Puppet is. You have something called a server. You also have something called agents. Agents will run on all those machines. and this server will be actually having a list of, they call it as, you also have something called Chef, Opscode Chef. That is again similar to this, and that is more popular these days. Opscode Chef has called that as recipes. So recipes are something like what you want to do on the infrastructure. I want to first, okay, remove the contents from temp directory, then install something called web server, then you install some other component, create a directory called slash data, download the file called Hadoop hyphen 1.0.1 from this this URL. You can still do automate the whole process using that. So that is what you call it as your configuration management. Fine. Perfect. Fine, then we'll actually catch up on the next class. We'll, yeah, go ahead. Sorry, Rakesh. Tell me, Rakesh. Go ahead. Okay, HDFS. Okay. 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 So whatever you have done was absolutely wrong. Did you realize that? Okay, so which means like when you say you have a single node cluster, the replication factor should be always one. Right, so when you say replication factor to be 20, your machine, your name node will be always in safe mode and it will never start. It will be throwing all your warnings. If you want to check that, you can actually check your log files. So basically, you should have not given 20 replication factor. The maximum replication factor recommended itself is your 3, or maximum people go for 5. So, but essentially 3 is a maximum thing that we want. Any kind of production level scenario will actually work out. So, and you specifying 20, that too for a single node cluster, would have actually screwed up the whole services and would have actually made your name node to be staying always on the safe mode. When you specify 20, where do you have the 20 more nodes? Yeah, so that is what the question answer is. Yeah. Okay, the block size would be 10 MB. No, the block size would be 10 MB. The block size should be 64, maximum is 64 MB. So because not every time you can expect everyone to load it as 640 MB so that you can get some 10 correct blocks. So there might be also 641 MB, which means 1 MB you will have extra. So which means that 1 MB would be again another HDFS blocks. HDFS blocks maximum size is 64 MB, minimum there is no limit. Okay. The remaining the remaining data would be stored as a block. Okay. Okay. That will not be the case. That will not be the case. That is why we have seen something called input formats, right? Each and every line, even though you say like, okay, every sentence is delimited by something called slash n. Every record would be split across only after a slash n character or a carriage written. So it will not be split in the middle. Even if it is split in the middle, you don't really need to worry about that. Okay, because it is internally a representation of Hadoop, but end of the day when you process using MapReduce, you essentially split across into different chunks. That is where the whole purpose of your shuffle and sort, combining all the records of your mappers come into picture and then collecting all together. It is pretty straightforward, similar to your word count example. Just compare it and let me know. Okay. Yes. Okay, like because more than me explaining things up, I want you to actually inspect into that because it is very straightforward. So the one script that you might actually want to see is your startall.sh. What does startall.sh do? The first it will actually start your name node, then your data node, second in name node, then your task job tracker, then your task tracker. So it is more of a structural approach. Okay, rather than having the end user to actually execute one by one sequentially based on dependency, you already have a script to actually go ahead with that. So that is what the whole funda is. It is all end of the day a shell script, Rakesh. It is all script. So shell script does not have any complexity. If you have any specific questions, let me know. So not the whole basic stuff. Yeah. Yeah. Thanks. See you all.